Good day everyone, it's still Mr. Afolabi, and today we are still going to art physics. I am here to complete the study of curved mirrors, the parameters involved in describing curved mirrors. This was where we stopped in our last class, and I promised you that we were going to move on to describing each of the parameters that I stated in the diagram. Of course, remember in the last class I told you that we have two types of mirrors. We have the concave and the convex. So by now you should know the type of mirror that is on the board there. This is what type of mirror? I guess so many of you made mistakes. This is a concave mirror or a convergent mirror. I told you that in the last class. So today let's just move on and describe all these parameters that we use in describing mirrors. The first thing there is the principal axis. The principal axis is this line OP. The line OP. And that's what's the principal axis? The horizontal line passing through the center of the mirror. Horizontal line. Horizontal line passing through center of mirror.
Oh, sorry.
That's the principal axis. This is the principal axis. The horizontal line that is passing through the center of the mirror. This is an horizontal line, isn't it? This is vertical, this is horizontal. So the horizontal line passing through the center of the mirror is the principal axis. The next thing we're going to discuss there is the pole of the mirror. Pole of mirror. Pole of mirror, and that's the point P. This point P here. This point P here is known as the pole of the mirror. Okay, the pole of the mirror is the center of the spherical mirror. You can see it is the geometrical center of the spherical mirror. The geometrical center of the spherical mirror. That's the pole of the mirror. The next thing we have to describe in that diagram is the center of curvature. The three, center of curvature, CP, center of curvature, CP. Center of curvature, CP, as you can see, is the center of the large sphere. You know the mirror is cut out of a large sphere. Remember I told you the mirror is cut out from a very large sphere. Now the center of that large sphere, where this mirror portion is cut out from, is known as the center of curvature. You know, it's a circular object. Okay, the spherical mirror is a circular object where you just cut out a particular portion. So the center of that spherical large object, where you cut out the portion of the mirror from, is known as the center of curvature. So this is the center of the large spherical mirror, where the mirror is cut out from, So that large sphere, where I cut the mirror from, the center of it is known as the center of curvature. The next thing I'm going to discuss here is the principal focus F. The principal focus F is is half of the radius of curvature, or rather is a point where every ray of light passing through will reflect parallel to the principal axis after reflection. What do I mean? Every ray of light, a point, I'm going to show you this in the diagram, a point where every ray of light parallel to the principal axis passes after reflection. I'm going to explain this using a diagram, because the principal axis is one of the major points when it comes to a curved mirror. Now, if I have a curved mirror like this concave mirror, which I have on the board, and I have my principal axis OP, okay, and I have my center of curvature on my principal focus. Now, every ray of light that is parallel to this principal axis. Remember, I discussed what the principal axis is. That's this horizontal line. Every ray of light parallel to this principal axis. You can see this ray of light. They are parallel to the principal axis. I told you in the previous classes, the best way to know a ray of light are those lines that are having arrow end. This is a ray of light. This is a ray of light. This is a ray of light. Now, every ray of light parallel to the principal axis. Once they hit the spherical mirror, they will reflect through the principal focus. Every ray of light, they reflect through the principal focus. So that's the definition you have here. That's a point where every ray of light parallel to the principal axis passes after reflection. Okay, all these ray of light, after reflecting on this surface, what happens? They all converge through the principal axis. And that's the definition for the principal axis. The next thing there is the radius of curvature. The radius of curvature number 5. Radius of curvature. radius of curvature R. Of course, you know that the radius of curvature is the distance between the center of curvature and the pole of the mirror. So if the radius of curvature is the distance between the center of curvature and the pole of the mirror, definitely it is also what? The radius of the large sphere. Remember, we discussed the center of curvature as the center of the large sphere. So if this is the center of the large sphere, then the distance between the center and that surface of the mirror will be what? The radius of the large sphere. The radius of the large sphere. Of the large sphere where mirror is cut from. Where mirror is cut from. Once again, let me just go through what we have gone through here under the mirror. The first thing is the principal axis. The principal axis is the horizontal line passing through the center of the mirror. Another thing here is the pole of the mirror, which is what? The center of the mirror. Then we have center of curvature. Center of curvature is the center of the last sphere where the mirror is cut out from. Then we have the principal focus. Principal focus is the point where every ray of light parallel to the principal axis will appear after reflection. Then we also have the radius of curvature. And radius of curvature is what? The radius of the large sphere. Still the radius of the large sphere where the mirror is cut out from. The last but not the least there is the principal focus, F. Number 6, principal focus. Or rather the focal point or focal length. We've discussed principal focus here. So the next thing is the principal focus or the length of the principal focus, F. Of course, the length of the principal focus, the distance of the principal focus from the pole of the mirror, F, is what we call the focal length. And of course, even without being asked, you can see that the focal length is half of the radius of curvature. When you divide the radius of curvature by 2, you get the focal length. So if I'm going to define the focal length now, I'll define the focal length as the distance between the principal focus and what? And the pole of the mirror. The distance between the principal focus and the pole of the mirror. The distance between principal focus and pole of mirror. And I just explained to you that mathematically, my F is what? The radius divided by 2. This is a very, very important thing for you to note. That in the analysis of a mirror, of a curved mirror, the focal length is always half of the radius of curvature. Plus, these definitions are very, very important in the analysis of mirror. Before our next class, I enjoin you to know these definitions because we'll be using them in consequent questions we are going to solve. Okay? And if you have any question with the video, remember to drop your comments under the video. Thank you.